Now fifth formula, using the first principle, it is if we are having log base a times x, okay, log, normally we are writing it log base a with x, and for log e we are not writing anything, we can just write it differentiate x, okay, sorry differentiate, sorry not x, log x, okay. So where a is greater than 0 and a is not equal to 1. Now what the result is, then the differentiation of log a with x is 1 upon x denominator, x times log e into a. Now let fx is equal to log a x. Now, when fx is equal to log ax, then fx plus h is equal to log a x plus h. Now definition of derivative. D upon dx of fx is equal to limit h approaches to 0 f x plus h minus fx upon h, okay. Now our question reduces to no, d by dx of is equal to limit h approaches to 0 log a x plus h minus log a x upon h, okay. Now this becomes limit h approaches to 0 log a 1 plus h upon x upon h, okay, again using property of log. In the last question, in the last formula, fourth, we have already done it, is log m minus log n is equal to log m upon n. Now here we are going to change one of the very nice thing, that is now limit h approaches to 0 log e. Now here it is log a, so we are writing log e 1 plus h upon x upon log e a with h. Again property for logarithm, what it is, log, if we are having log a lambda, then we can write it log e lambda upon log a, okay. So because why we have done this one, because we have the property for the limits, okay. So that's why we have converted it into log e. Now this becomes 1 upon log limit h approaches to 0 1 plus h upon x upon h upon x times 1 by x, okay. Now this becomes 1 upon x limit h approaches to 0 log e 1 plus x upon x, that is 1. x approaches to 0. Okay. So, we can write it directly that now derivation for, hence derivation for log a x is equal to 1 upon x simple.